Hello everyone, this is Evan Ross. The topic that I'm going to teach today is all about ordinary differential equations, ODE. It has 5 methods. The first order, Euler's method. The second order, the Ralston's method, Midpoint Method, and Heun's method. And the fourth order, or the RK4 or the Runge Kutta fourth order method. Euler's method, also called Euler-Cauchy or the point slope method, is in determining this method uses the slope at the beginning of the interval as a approximation of the average slope over the whole interval. The formula in getting the root in Euler's method is this, because it is only a first order, yi plus 1 equals to yi, or the initial y, plus f of xy times h. Next, the second order differential equation. First, midpoint method. Also called the improved polygon, or the modified Euler's method. By the way, these methods are inside the Runge-Kutta method. These are the classifications inside the Runge-Kutta method. Next is the second order differential equation, midpoint method. The midpoint method, it also uses the Euler's method to predict a value of y at the midpoint of the interval. It is more superior to Euler's method because it utilizes a slope estimate at the midpoint of the prediction interval. The formula in this method is this. First, you must find the K1 and the K2. K1 is equals to f of xy, which means that we substitute the x and y to the equation. K2, f of x I plus 1 half h. The h is the step size. Yi plus 1 half k 1h. This is the k1 and h is the step size. Thus, in determining the yi plus 1 equals to yi plus k2 times step size. Next, another second order differential equation is the Ralston's method. It is a second order method and a part of Runge-Kutta method. By approximating the solution of the initial value problem, it uses the Richardson extrapolation in determining the root required. The formula in Ralston method is equals to K1 f of xi, f of x and y, like in this midpoint method, and K2 f of xi plus 3/4 each step size, yi plus 3/4 also times each. In determining the yi plus 1 is equals to yi plus 1/2 k1 plus 1/2 k2 and 1/3 k1, then 2/3 k2 times each. Next, another second order differential equation is the Heun's method. It is a determination of two derivatives for the interval at the initial point and end point. The derivatives are averaged to obtain an improved estimate of the slope for the entire interval. It is a predictive corrective approach. The formula in used method is this: K1 is to f x and y, xi, yi, same to the Ralston and midpoint. In finding the K2, f of xi plus h, and finding the yi plus k1h, and finding the yi plus 1, so yi plus 1/2 k1 plus 1/2 k2 times h. Lastly, another order is the fourth order differential equation. Another category. Inside this fourth order differential equation is the RK4 or the Runge, Kutta fourth order method. The most popular RK method is the RK4. The formula is commonly called the classical RK4 method. In terms of the formula, it is similar to the Simpson's rule in terms of the concept. In addition, RK4 method is similar to Heun's method in the multiple estimates of the slope. The formula in RK4 is this: K1, K2, K3, K4. K4 because it is a fourth order differential equation. K1, f of x, I, yi, same to the second order differential equations. K2, f of x, xi, plus 1/2 h, yi plus 1/2 k1h. It is the same to the midpoint method in K2. Next, K3. The same for the K2, but This time, the K1 in this part will be K2. You will get K4 f of xi plus h plus 2 yi plus k3 h. The same in the K2 of the units method. In determining the yi plus 1, yi equals to 1, 6, k1 plus 2k2 plus 2k3 plus k4 times h for the step size. Let's make an example. dy dx equals to 4e raised to 0.8x minus 0.51. The initial condition of x equals 0. The initial condition of y equals to 2, and the step size is 1. First, Euler's method. K1 is Euler's method. Yi plus 1 is equals to 0. 2 for the initial condition plus f of x and y for e 0.8 times 0 minus 0.5 times 2 times h or 1. 2 plus, the answer will be 3 times 1. yi plus 1 equals to 5. Next is the midpoint method. Get the K1 f of xy which means that 3. Then find the K2 is to f xi plus 1/2 h yi plus 1/2 k1 h, which means that f of x will be 1/2 and yi is 3.5. In substituting the values for e, it equals to 0.8, 1/2 times 1/2 minus 0.5, 3.5. The answer will be 4.2173. Then, substitute to the formula yi plus 1 equals to yi or the 2 plus 4.2173 times 1. The answer will be 6.2173. Next, Ralston's method. XO will remain 0. So K1 equals to f xi plus xi yi. The answer will be 3. K2 is to f xi plus 3/4 h 2 yi plus 3/4 k1 and h. The f of x and y will be 3/4, f of 3/4 and 2.75. Actually, in substituting 4e raised to 0.8 times 3/4 minus 0.5, 2.75. The answer would be 5.9135. Yi plus 1 in substituting the formula, 2 plus 1/3 the K1 3 plus 2/3 K2 5.9135 times 1 equals to 6.9423. Next, the units method. K1 f of x and y was 3, same with this. K2 f of xi plus 8 yi was to K1 each. The answer will be f1 and 5. In substituting to the formula, answer will be 6.4022. Then we substitute to the formula, yi plus 1 equals to yi for the 2 plus 1/2 K1 or 3 plus 1/2 K2 or the 6.4022 times h or 1 equals to 6.711. Next, lastly, the Runge Kutta method. Or the RT4. K1 will be f of x and y equals to 3. K2 equals to f xi f xi plus 1/2 h yi plus 1/2 K1 h. The f of xi equals to 1/2 and 3.5. The answer will be 4.2173. K2, K3, the same with this formula. The f of x equals to f of x and y equals to 1/2 4.1087. The answer will be 3.9189. K4, f of xi plus h, y, K3, h, the same with this with the units method. The f of x and y will be 1 and 5.9129. The answer will be 5.9457. Substitute to the formula, yi plus 1 equals to yi or 2 plus 1, 6. K1 will be 3 plus 2 times K2 or the 4.2173 plus 2 times the K3, 3.189, plus the K4, 5.9457 times the step size. Then yi plus 1 equals to 6.2863. The true value in this equation is 3. Thus, when we substitute the initial conditions to the equation, the answer will be 3. So, to get near to the 3, you must add the step size to the 0, and the answer that you get in this equation will be the new y. Then repeat the method in each. Then you get near to the true value, which means 3.